All right, so in our previous video, we took the square root of x on the interval from x's from 1 to 4, rotated around the x-axis. Well, my problem today, our first problem today, is that we're going to now find that volume by taking that same function, but now we're going to rotate it around the y-axis from y is equal 1 to 2. Okay? So, first off, I'm just kind of curious on what that's going to look like. So let's sketch it. Okay, there we go. The function, again, is the square root of x, which will look something like this. Now we're going from y equals 1 to y equals 2. So let's say 1's right here. So we're going to get rid of this part. And let's say 2 is right here. So maybe to right about there. And now we're rotating it around the y-axis. Now notice these still correspond because this is y equals the square root of x. It still corresponds to 1 and 4, right? The square root of 1 is 1 and the square root of 4 is 2. So I still picked it to be the same x interval, but now we're looking at a y interval from 1 to 2 because we're rotating around the y-axis. So let's head to GeoGebra and let's see if we can find this one. Okay, this is what it looked like when we rotated it around the x-axis. What's it going to look like when we rotate that same region around the y-axis? And all I have to do is come in here and I can change that x to a y. Let's back that out. All right, so there's our region. The green axis is our y-axis, and let's rotate it around. Okay, almost looks like a wide funnel, or if we flipped it this way, maybe like a lampshade, something like that. And I hope you can see that from this sketch, right? We're going to rotate it around. It's going to give you a very wide circle on the top, a very narrow circle on the bottom. So how do we do this? Well, we have said that the volume is going to be the volumes of the cylinders pi y squared dx, correct? But now our cylinders are going to be rotating this way. So let's think about the new dimensions of our cylinder. The height is this, which is no longer dx, that's now dy. This distance, the radius of our cylinder that gets rotated around, is no longer y, it's actually the x value, right? So here's my point. This radius is the x value, so it has to be pi x squared dy. And it makes sense that it's dy. We're rotating around the y-axis, and we're rotating from y's from 1 to 2. So you can go 1 to 2 here, because remember, we're integrating with respect to y's, so we want our bounds to be for y's. All right? So here we go. This is going to be the integral. Let's take the pi out. 1 to 2 of x squared. Well, what's x? Well, we know that y equals the square root of x. So what does x equal? X equals y squared. Okay, and we needed to have a y in there because we're integrating with respect to y. So we have pi times the integral from 1 to 2 of y to the 4th dy, which is going to be pi times antiderivative 1/5 y to the 5th from 1 to 2. So pi times, let's see here, 2 to the 5th is 32, so we have 32 fifths minus, substitute in a 1 would be 1/5. So we get 31 pi over 5. Cool? All right. So that's how we handle rotating around the y-axis. Not too difficult. I just always find it helpful to draw my rectangle, to picture the cylinder, to label in the dimensions. All right, see if you can handle that. Thanks for watching.